Right, Nana? So is it audible, right? So last class what we were discussing now? Hello. So what is the concentration of pure water? Means molarity. Molarity. So we discussed Ka, right? We discussed Kb. We discussed pH, pOH, relationship between Ka and Kb, and pH and pOH. Yes or no? For acid dissociation constant, Ka, right? So what is the relationship between Ka and pKb? Ka and pKb. Ka, Kb, nothing but pKa, pKb. So what is the pKa? pKa is equals to minus log Ka, right? pKb is nothing but minus log Kb, minus log Kb, right? So what is the relationship which I gave? pKa plus pKb equals to pKw. pKw value is how much? 14. So pKa plus pKb equals to 14. The same mode, pH plus pOH is equals to 14, particularly at 25 degrees centigrade. At 25 degrees centigrade. And acid dissociation constant also we discussed, right? So Ka for weak acids, CH3 Ostwald dilution law gives rise to CH3 COO minus H plus, right? If I'm taking the concentration is like this. Hello. So C minus C alpha, C alpha, C alpha. So directly I am writing Ka is equals to C alpha square by, right, 1 minus alpha. So how we got this directly? So means Ka is equals to C alpha by C into 1 minus alpha. CC get cancelled. So Ka is equals to C alpha square by 1 minus alpha. Ka is equals to C alpha square by 1 minus alpha. So H plus ion concentration for the weak acids, how we need to calculate? H plus is nothing but C alpha, nana. H plus ion concentration is nothing but C alpha. So alpha value, how can we do the alpha value over there? C alpha. K is equal, H plus ion is equals to C alpha. So here is how can we solve the alpha value here? I told you in the beginning, 1 is far greater than alpha, so we can neglect Ka is equals to C alpha square. So we can neglect the alpha. C alpha square means alpha square is equals to Ka by C. Alpha is equals to under root Ka by C. So alpha value will C into alpha value Ka by C. So H plus ion concentration is nothing but under root Ka into C. Write it down. నేను రాసావా? The same, Nana. OH minus concentration also same we did, right? So then pH I already explained. H plus ion concentration nothing but 10 to the power of minus x is nothing but H plus ion concentration. X is equals to, you can take pH, Nana. H plus ion concentration is equals to 10 to the power of minus pH. 10 to the power of minus pH. So we can write like this: log, apply the log H plus ion concentration is equals to minus pH, because log nothing but 10 to the power of some x, right? So pH is equals to minus log H plus ion concentration, minus log H plus ion concentration. The same mode, OH minus ion concentration. OH minus ion concentration is equals to 10 to the power of minus Y. So now I can, Y is equals to, we can write POH, right? So OH minus ion concentration is equals to 10 to the power of minus POH. POH. So log OH minus ion concentration equals to minus POH. POH is equals to minus log OH minus ion concentration. So this already we discussed. And KW also we discussed, no? What exactly the KW? H plus ion concentration. KW is equals to H plus ion concentration into OH minus ion concentration. H plus ion concentration into OH minus ion concentration. So can I write like this? H plus ion concentration to OH minus ion concentration is equals to KW. Apply the log, multiply the log H plus ion concentration into OH minus ion concentration is equals to log KW. Log A into B, nothing but log A plus log B, no. Log A into B is equals to log A plus log B. So here is log H plus log OH minus is equals to log KW, multiply with negative with all, minus log KW plus minus log OH minus log KW. Minus log H plus is nothing but what? What, no? pH plus POH is equals to pKW. pH plus POH is equals to pKW. So at 25 degrees centigrade, right? So at 25 degrees centigrade, KW is nothing but what? 10 to the power of minus 14. So here is pH plus POH is equals to, right, 14. So very, very important, these formulas. pH plus POH is equals to 14. Done? Right. This ionization constant Kw we discussed, right? Kw is equals to ionic product of water or ionization constant of water. Nana Kw is equals to S plus into OH minus. We already discussed. So at 25 degrees centigrade, I already told that this is experimental data. So 10 to the power of minus 14 Kw value. So for pure water, H plus and OH minus both are same, is nothing but 10 to the power of minus 7. The product of molar concentration of H plus and OH minus were nothing but Kw. So at 25 degrees centigrade is very, very important. Right. So number of moles dissociated by, so degree of dissociation or ionization, number of moles dissociated by number of moles initially taken. So this is number of moles dissociated 10 to the power of minus 7 by initially the concentration is 55.5 nano. So degree of ionization, so write it down, degree of ionization 10 to the power of minus 7 by 55.5, so write it down. We can take alpha also, degree of ionization of water, number of moles dissociated by number of moles initially taken. Write it down that. Chandra, Egna Rasava. So this value, right, 25 degrees centigrade. Yeah, this value 1.8 into 10 to the power of minus 9 nano is nothing but in percentage 1.8 into 10 to the power of minus 7. So this percentage we need to remember. Sometimes they are asking this percentage 1.8 10 to the power of minus 7, 10 to the power of minus 7 by 55.5 value, nothing but 1.8 into 10 to the power of minus 9. In percentage means into 100, into 100 means 1.8 into 10 to the power of minus 7, minus 7 percentage, 1.8 into 10 to the power of minus 7 at 25 degrees centigrade. Value గుర్తుపెట్టుకోవాలి. Done? Right, right. So in neutral solution, right, H plus OA concentration is equals to OH minus ion concentration. Acidic means what? H plus ion concentration is greater than OH minus. In basic solution, what happens? OH minus concentration is more, H plus concentration is less than OH minus ion concentration. So K equilibrium. No? So H plus concentration into OH minus ion concentration. So we know 10 to the power of minus 7, 10 to the power of minus 7, nothing but 10 to the power of minus 14. Right? By 55 pi is 1.8 into 10 to the power of minus 16. K equilibrium value. So just write that and write this also. Then next one, pH scale. So pH concentration of H plus ion written in simplified, right? I already told you. So this is a Sorensen, the pH scale, generally Sorensen scale also we can say. pH is defined as negative logarithm of H plus ion concentration. pH is equals to minus log H plus ion concentration. Minus log H plus ion concentration, right? H plus ion concentration are like that. Already we discussed this, so no need to write. So in a different, right, no? H plus ion concentration, pH scale. So 1 to 14, the pH scale at 25 degrees centigrade, only we will take. So 1 to 14 scale. 0, 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You know, so if the 0 means more pH, right? So pH is like this. Up to 7 means neutral, right? 7 means neutral. So if it is increasing, the pH value is also increasing. So means what? The pH value I told you in the last class. pH is inversely proportional to H plus ion concentration. If H plus ion concentration increases, so pH is decreases. So pH value increasing means H plus value is decreasing, means so 6 means 6, pH 6 and pH 2. Which is stronger acid? Hello. pH 1 is 6 is there, pH 1 is 2 is there. pH 2 is stronger acid. This is the stronger acid. Okay. Neutral. 7 means neutral. And increasing, so basic nature is increasing. Here is 7, 8 like. So pH and pOH I already discussed. So pH plus pOH is 25 degrees centigrade. pH plus pOH is equals to 14 nano. pH plus pOH is 14. Particularly, this is very important at 25 degrees centigrade. I already gave you this one. pH scale, pH is less than 7 means acidic, or pOH is greater than 7 also we can say the acidic. So because pH plus pOH is equals to 14. pH plus pOH is equals to 14. If pH 7 is equals means neutral, pOH 7 also be neutral. So pH is greater than 7 is nothing but basic, or pH is less than 7, that is also basic. So write it down this. So a lot of people are confusing in case of POH, Nana. So write it down, pH and POH both at 25 degrees centigrade. Then completed. No transcribe. POH value. నేను ఇచ్చినాను. Then completed. Hello. So I already told you that H plus ion concentration, tendency of H plus increases, pH is decreases, right? I already told you this pH is H plus ion concentration is inversely proportional to pH. So OH minus ion concentration increases, pH is increasing. So OH minus ion concentration is directly proportional to pH. This is important. Base strength. OH minus ion concentration is increases, pH is increases. This is very, very important information. So a lot of people are confusing in this case. Write it down. ఏమవుతుందా? అవుతుంది. వస్తుంది. Done, Anna. Dissociation of water is endothermic, no? Write it down. Dissociation of water is endothermic. Dissociation of water is endothermic. If temperature increases, Kw is also increases. If temperature decreases, Kw is decreases. So Kw is nothing but what? H plus ion concentration into OH minus ion concentration. Temperature increases, Kw is increases. Temperature increases, Kw is increases. Because water is less dissociationistic. So pH scale, so Kw value at 25 degrees centigrade, I told you 10 to the power of minus 14. At 40 degrees centigrade, so the value is keep on changing. 2.9 into 10 to the power of minus 14. So at 90 degrees centigrade, 38.02 into 10 to the power of minus 14. So means Kw at generally will take a 25 degrees centigrade as the standard value. So if the temperature changes, Kw is also changes. So write it down this, write the values. Then so temperature decreases, Kw is decreases. So Kw decreases from 10 to the power of minus 14, right? So 0.293 at 10 degrees centigrade now. 10 to the power of minus 14 to 0.293. So generally pH scale is 7 midpoint when 25 degrees centigrade. This is very very important, we need to understand. At 25 degrees centigrade, so the pH scale midpoint is 7, right? 7 means neutral. 0 to 7, 7 to 14, yes or no? Midpoint is 7 when 25 degrees centigrade. But where is in case of 10 degrees centigrade, if you are instead of 25, if you are taking the 10, so the value is 7 is going to 7.27 now. 7.27. So 7.27 the midpoint of the pH scale when 10 degrees centigrade. Write that point also. .27. So particularly we will take 25 degrees centigrade only. I keep on telling n number of times 25 degrees centigrade. This value no need to remember, of course. So pH scale is increasing, means temperature increasing, Kw is increasing. So at what at 90 degrees centigrade. I already gave you 38.02, right? So if you are calculating, the midpoint would be 6.21. So at 90 degrees centigrade, at 25 degrees centigrade, at 25 degrees centigrade, compare with always. We will take the pH scale at 25 degrees centigrade only, Nana. Hello. But at 90 degrees centigrade, so 0, this is 6.21, midpoint. So 6.21 means neutral. So here is one important question they'll ask. When 90 degrees centigrade, the pH is 6.21, the solution is acidic, basic and neutral. They'll ask the question like that. Now what, tell me the answer. At 90 degrees centigrade, 6.21, the pH is 6.21. The solution is acidic or basic or neutral. At 90 degrees centigrade. Like 6.21 means neutral. The same question, the pH is 6.21 at 25 degrees centigrade. The solution is, hello. The pH is 6.21 at 25 degrees centigrade. 25 degrees centigrade. What it is? Acidic or basic or neutral? At 25 degrees centigrade, this is acidic. Acidic. Don't confuse. Meghna, అర్థమవుతుందా? సోనా? So this type of questions they are frequently asking based on temperature and pH scale. Right, Nana. pH calculations. Put the heading pH calculations. pH calculation. Acidic solution. First case we'll discuss acidic solution. pH calculations. pH calculation. First one, case 1, acidic solution. Acidic solution. Acidic solution. Acid is dissolved in water. Acid is dissolved in water. Acid is dissolved in water. So in acid solution, first strong acid is dissolved in water. So first one we'll discuss strong acid dissolved in water. Dissolved in First condition we'll discuss strong acid dissolved in water. Second question, second type of pH calculations we'll do mixture of strong acids. Mixture of strong acids are dissolved in water. So third calculations, weak acid dissolved in water. Weak acid dissolved in water. We are going to calculate all this. The mixture of strong acid plus weak acid dissolved in water. Fifth type of mixture of weak acids dissolved in water. Mixture of weak acids dissolved in water. Last one we'll discuss. Polyprotic acid. Polyprotic acids. Write it down. Strong acid dissolved in water. Mixture of strong acids dissolved in water. So first two conditions no common ion effect. So these two conditions, no common ion effect. In this third case onwards, in all the cases common ion effect will be common ion effect will present, otherwise common ion effect is there applied. Common ion effect is applied. What is the common ion effect? I told you, if the same ion, the Chatelier principle. So like that, write it down. This is case 1. Case 1. So case 2 will discuss base solutions, basic solutions. Base dissolved in water. So of course first we'll finish this one, then we'll come to Then Ross completed. Hello. So put the one case one strong acids first. We'll discuss strong acid. Case one strong acid. Strong acid means what? 100% dissociation is takes place. Yes or no? Right? So strong acids means acid dissolved in water, right? I told you. Acid dissolved in water. For example, HA, acid dissolved in water, this is H plus plus, A minus. 100% dissociation is takes place. And along with water is also is there. Water also H plus plus, OH minus. So H plus. So how can we calculate the pH, right? Now the H plus is coming from acid as well as water. Write it down. H plus is coming from acid as well as water. H plus is coming from acid as well as water. Here is try to understand. Here is very simple calculations from experimentally we determined that. For example, 10 to the power of minus 1 molar aqueous HCl. Okay. 10 to the power of minus 2 molar aqueous HCl. 10 to the power of minus 3 molar aqueous HCl. 10 to the power of minus 4 molar aqueous HCl. 10 to the power of 10 to the power of minus 6 molar aqueous HCl. 10 to the power of minus 7 molar aqueous HCl. 10 to the power of minus 8 molar aqueous HCl. 10 to the power of minus 9 molar aqueous HCl. Hello. So here try to understand up to 10 to the power of minus 6 nano. The H plus which is coming from acid only we will consider. The H plus which is coming from the water we will neglect, right? So here up to here H plus is coming from H plus which is coming from water we are neglecting. Okay, write it down. H plus which is coming from water we are neglecting. Because the percentage of error is less than 1%, so that doesn't affect. But in these two cases, so means H plus which is coming from only acid. We consider only acid. But in this case, H plus which is coming from acid plus water. Acid plus water. After 10 to the power of minus 9, the H plus will consider only water. Only water. So write it down. Very, very, very important one. So directly we can say up to 10 to the power of strong acids means, for example, 10 to the power of minus 2 molar aqueous HCl. What is its pH? So pH is directly we can say 2. pH is equals to minus log H plus ion concentration. So here is pH is equals to what? No. 6. Here is pH is equals to 5. Here is pH is equals to 4. Directly we can say pH is equals to 3 here, 2, 1. Write it down. Then run. So here we cannot say 7, here is we cannot say 8. So here is pH, no? We will get how much? It is 6.79. Here is pH is equals to 6.97. So I'll give the chart, list of H plus ion concentrations. Write a concentration of HCl, concentration of HCl, source of H plus, source of H plus, concentration of source of H plus, write it down, and H plus ion concentration pH. H plus ion concentration pH. If 10 to the power of minus 6 up to 10 to the power of minus 6 aqueous HCl. So source of HCl, source of H plus is only acid. Only acid. The concentration of H plus ion is 10 to the power of minus 6. pH is equals to 6 now. Directly we can write. So 10 to the power of minus 7 the source of H plus is coming from acid plus water. 10 to the power of minus 8 also the source of H plus, acid plus water. So I'll explain why it is. Directly I am giving the values, right? So 10 to the power of minus 9. So only water we will take over here. Only water now. Here is we can say 1.62 into 10 to the power of minus 7. So 6.79. 1.05 into 10 to the power of minus 7 will get 6.97. Here is 10 to the power of minus 7 will get 7. So this table is very important. Just note it down. I'll explain why. Up to 10 to the power of minus 6 nana, if you are neglecting the water, so the percentage of error we will get only less than 1%. But here if you are 10 to the power of minus 7 cases, if you are neglecting the water, the percentage of error we will get more than 62%. 62%. That's the reason 10 to the power of minus 7 and 10 to the power of minus 8 cases, we won't neglect the water which is coming from the H plus. Okay? From H plus is coming from water. Okay? Of course. So write it down. Very important one. You know? So they are asking the questions from this particular area here. This area. Put the 5 star. Put 5 star. So because here we are neglecting up to 10 to the power of 6. I told you here. Up to 10 to the power of 6 we are neglecting. So water which is coming from the water, right? H plus which is coming from water we are neglecting because the percentage of error is less than 1%. Percentage of error is less than 1%. If in 10 to the power of minus 6, minus 7 and minus 8 cases, the percentage of error is more than 62%. That's the reason We are considering the H plus which is coming from the water also. Write a question. Calculate pH of 10 to the power of minus 1 molar aqueous HCl. Question number 1. Calculate pH 10 to the power of minus 5 molar aqueous HCl. Question number 3. 10 to the power of minus 7 molar aqueous HCl. Calculate 10 to the power of minus 8 molar aqueous HCl. 10 to the power of minus 3 molar aqueous HNO3. Question number 6. 10 to the power of minus 5 molar aqueous H2SO4. Come on, 6 questions which I gave to calculate the pH of strong acids, of course. Come on, do it. Do it fast. Come on, do it. Servicing. Temperature కూడా తక్కువ. వేయించాము. Nomenclature, in the nomenclature, one of the easy మేఘ్నా చేసావా? ఇషా చేసావా? తెచ్చాను. చేయకపోయినా చూడకపోయినా చెప్పింది ఈజీ టాస్కే కదా. సాల్వ్ చేయమని చెప్పి ఈజీ. మనం చూడాలిరా ఆన్సర్స్ అప్ టు 10 to the power of -1 10 to the power of -5 ఇంతకుముందు చెప్పింది రైట్. ఇక్కడ ఇచ్చి హెచ్ ప్లస్ అండ్ కాన్సన్ట్రేషన్ ఎంత వస్తుందిరా 10 to the power of -1 nothing but 0.1. I already told you simply like that H plus ion concentration is equals to 10 to the power of minus pH. So means directly we can write there is pH is equals to 1, in this case pH is equals to 5, here is pH is equals to 7. Correct or wrong? Huh? pH is equals to 7 is wrong because I already told you 6.79. Here is pH is equals to 6.97. Only the difference is 7997. Here is pH is equals to 3. So here is pH is equals to 5. 5. pH is equals to last one. pH is equals to what? Because H2SO4 no. Gives rise to 2H plus is giving, right? 2H plus ions. 2 into 10 to the power of -5. So pH is equals to minus log H plus ion concentration. Right? 5 minus log 2. Log 2 is how much? 0.3. So 4.7. 4.7. Okay, not 5. Otherwise, I told you like this also we can do raw. So 2 into 10 to the power of -5. Right, this is H plus ion concentration. So they need 10 to the power of power look రాయాలంటే ఏంటి? So 10 to the power of 0.3 into 10 to the power of -5. So nothing but 10 to the power of -4.7. Right, pH is equals to 4.7. Simple. Done? So I already told you strong acids, from mixture of strong acids we will do tomorrow. M1V1 plus M2V2. So there onwards we will do tomorrow. So if possible, try to solve the questions, pH calculation questions.